welcome to today's GVERSE Geomodeling webinar. I'm very excited to be presenting this. This is new technology that we're going to be releasing in the 2017.1 release due out in November. We're finishing up the development on that as we speak, and I will be presenting many of the new features and functionality within the GVERSE Geomodeling features. GVERSE Geomodeling is built upon existing and new technology that will be familiar to some of you who have already used Smart Section. The interfaces are very similar, but the technology behind it has been significantly upgraded. We are in a full 64-bit map, cross-section, and 3D view environment. We have new map and 3D view panels that take advantage of new docking technology we've incorporated into the interface. The cross-sections and fence diagrams are interactive between the 2D and the 3D visualization that you see there on the right. We also are going to be taking advantage of the relatively new buffered projected cross-sections, which is automatic cross-section generation by simply drawing a line of section, and then wells within a certain buffer distance will be automatically projected into the line of section and generate you a cross-section on the fly. We, of course, have real-time surface modeling that's done by the topology engine in the background. Our new 3D view is built upon new technology. It's all full 64-bit, all built with the latest visualization technology we can find. We'll be showing you surface overlays, new well grouping features, clipping planes to cut down the edges of the 3D view, 3D regions, which allows you to focus in on your areas of interest. And finally, in the workflow, I'll be doing a well planning using GVERSE Planner in the model that we will be creating in the workflow. And finally, I will show you how you can port your existing X-section cross-sections, which you may have a large inventory of, very easily into the GVERSE Geomodeling environment, so you can preserve that inventory and that investment you made in X-section cross-sections. With that, let me jump into the live demonstration. You're currently viewing the map view of GVERSE Geomodeling. It's very familiar to those people that are using Smart Section. We tried to incorporate much of the familiar UI of existing applications, so the learning curve will be very, very slow. What we've added significantly is both a map view and a 3D view into the user interface, plus new docking panels here. These panels can be very easily moved from side to side, docked anywhere you want to, either left or right, full screen, or taken off to a separate monitor. Unfortunately, I just have one monitor here, so I have to stay with that one screen. We also have data panels that are tied to the particular view you're looking at. I'm now in 2D map view, therefore I'm looking at a 2D data panel showing you all the 2D objects that you have available for display in the map. If I click the focus over here on the 3D map view, we have a 3D data panel showing all of the different objects that are in 3D that we can view. This is what we're going to be doing during the workflow. Now let's just go ahead and start working through our cross-section. This, of course, is probably a very familiar teapot dome. It's a nice data set for showing structural and stratigraphic features. So let's go ahead and open up a east-west cross-section right through the heart of the feature. And you'll see immediately when I open up that cross section, you'll see the corresponding fence diagram show in the 3D view. It's very easy to navigate. I'm navigating with the mouse wheel and mouse buttons and mouse. And anything I do to the cross section, I immediately see in 3D because we're actually accessing the same 3D objects in memory space. So for example, if I turn on the interpolation fill, you'll immediately see the interpolation fill in the fence diagram. Let's open up another one, a north-south cross-section, and start building a series of fence diagrams across the feature. And again, let's turn on the interpolation fill. So it's basically what you see is what you get. Again, as many of these well-to-well cross sections that you have, you can show as fence diagrams. I can turn on the associated well groups that will show the corresponding lathe view of the gamma ray that I'm interpolating across and between the wells. Now let's use the relatively new buffered projected cross sections. This was first introduced in 2016, has been further enhanced for 2017.1. I simply just lay out a line of section and it will buffer in any wells that are within a preset buffer distance into a projected cross section. And you'll notice then I've got that same projected cross section showing right here in the 3D view. Let's turn on the display of the color fill of the lithologies. These are determined by whatever lithologies you have defined for your stratigraphic column in the Strat Column Manager. Now, in addition to showing the lithology fill, we also have these property panels that will allow us to show different properties of our whatever 3D object we have in there. For example, I'm going to turn on the seismic backdrop, change the opacity to 100% and the opacity of the lithology fill to about 50%. And you can see I'm displaying both the depth converted seismic backdrop, and this is being depth converted on the fly using the velocity model that I built over in SizeVision. And I'm also showing the lithology fill, and I can move these buffered projected cross sections anywhere I want to within the model, and it immediately buffers up any wells that are within the buffer distance. I can also select this line of section and use the arrow keys to simply scroll through my model. This is a nice feature for scanning through your structure or your stratigraphy without having to do a whole lot of well-to-well or manually projected cross sections. Just do a few of these buffer projected cross sections and just drag them around wherever you want to, and you can very quickly look at what's going on structurally and stratigraphically within your feature. Let's go ahead and close the projected cross section for now. Don't need to save it. And let's focus over here on the 3D view. When I click over here on the 3D view, again, the data panel, the 3D data panel becomes active. Now I can turn on any of the surfaces that I'm currently modeling with the topology engine. Let's go ahead and turn them all on and just limit maybe to just some of the ones that we're interested in. Let's come over here and juice up the horizontal or the vertical exaggeration just a little bit. Here we go. You can still see your well-to-well cross sections with your interpolation fill shown in there. I can also turn on my faults. These faults are coming in from depth converted faults, coming in again from SizeVision, being depth converted on the fly using the velocity model. And let's look at the geosurface model properties. This is showing you what you're using in the topology engine. These are the surfaces that I've brought in from the active stratigraphic column, and I've set up a hierarchy of constraints. My Dakota from SizeVision is being sourced from a depth converted surface dynamically through the velocity model from SizeVision. I've said that the Dakota from SizeVision is going to control the conformance of the Dakota coming in from the well picks. That in turn will control the conformance of the C1 dolomite. That's part of the 10 sleep in the area, and that's going to be controlled by the Dakota conformance. So I'm going to switch over here on the map view from the Dakota to the C1 dolomite, and notice it is only modeled over the convex hull of the picks based upon the C1 dolomite in well base. But by applying the conformance technology, again, you can see the C1 dolomite at the base here. Applying the conformance technology, it will immediately conform to that upper surface, and in both map view and 3D view, we're again seeing the same thing. So let's look at everything. Let's turn off the well groups. Let's turn off the cross sections for now, and faults. And let's just look at the Dakota and the C1 dolomite in 3D for now. So there's the Dakota on the top and the C1 dolomite at the base. And over here on the map view, let's turn on the Dakota. And let's look at a new feature we've put in the map view, and that is called the quick pick for the surface interwell points. So I'm going to turn on quick pick mode here and turn on my add interwell points. Make sure we're on the Dakota surface. And I can now seed in multiple quick picks. Now these quick picks simply take on the value of the surface where I picked it. So that's 844, a little bit more, 845 feet subsea depth. Now these are not being put into the database or the model yet. They're just there for my use in visualizing and moving around. I can move them around anywhere I want to. I have multi-level undo, a multi-level redo, and once I'm ready to commit it to the database, I simply save the quick picks. It saves it to the database and then is immediately modeled with the topology engine. Again, you can see the C1 dolomite is being influenced and conformed by the extents of the Dakota above it. Likewise, I can go ahead and select these quick picks and delete them, and then save the deletions, and then everything goes back the way it was. Now again, whatever I'm looking at in the map view or the cross-section view is immediately visualized in the 3D view. So for example, if I want to change the color of the fill from the default rainbow to say a stratum, this is a very nice color fill here. Again, once I've done it on the map view, immediately you see the results of it in the 3D view. Now let's look at some other features of the 3D view. If I go to the properties panel, I can see I can do a number of overlays. I have any overlay that's any kind of GeoAtlas map I can overlay on any of these structures. So for example, if I want to put the land grid on there, and I'll zoom in a little bit, you can see the land grid on there. I can change it to culture, overlay, or any kind of isomap. I have a stress map field that's showing the areas of high and low differential stress on that structure. I can show any kind of overlay that I please. In addition to that, I have the ability to turn on the map image. It's being placed automatically at the base of my 3D view. This is the same map view as I'm seeing over here in the 2D map view pane. Okay, let's talk about well groups. Well groups is a way of subsetting the number of wells that you may want to see. Now, this is a relatively small area. These are sections, but if you have a very large area with many hundreds of miles of map display and many thousands of wells, you probably don't want to put many tens of thousands of wells in a 3D view. It'll just look like a forest with a bunch of trees in it. So let's go ahead and do a well group by just highlighting with the selection box a number of wells. And we're going to group these wells, and we're going to call these our teapot dome wells. It adds it to our well groups over here. Here's teapot dome wells, and you can just immediately see that they're being displayed over in the 3D view as soon as they're created. I can manage my well list. This is the well list of those wells. I can add or subtract wells dynamically. I can even apply filters, so you can make well groups based upon not only just the aerial selection, but a filter selection. Over here in the 3D view, I can also look at my properties. I can show labels. So let's go ahead and show the labels at the surface location. And let's do the operator and well name. There they immediately show up. And maybe the symbol, and we'll put that at the bottom, and that will be the well symbol showing up at the bottom. So you can format your well data. In addition to that, we can show tops. So we can say if you want to label the Dakota and C1 Dolomite tops, any fault cuts. We can put logs on here. You can label any of the logs. These are going to be your default log names from Prism. And we're also adding data postings. Right now we have perforations. By the time we finish this, we will have perforations, completion, and completion stages that will be available for posting. Now, in addition to doing a well group of a subsetted region of wells, we can also subset the overall region. Again, if you're working in a very, very large area, you may not want to be geomodeling over many hundreds of square miles. Maybe you want to focus in on a reservoir scale of many tens of square miles. So we have the ability on our map to create a subsetted region. You can do one or more of these subsetted regions. And we're going to do a subsetted region of a place where we're going to be doing a well plan. So we're going to call this our proposed well region. Once that region is defined, we can go ahead and then subset. It immediately zooms your map in to the area you're looking at, and it also subsets your 3D view to that particular area. Now that we have that subsetted, let's go ahead and turn on our cross section that we're going to be doing our well planning on. This is, I've got a proposed well here. Let me change from the that color to that color, a little easier to see it. So this is our projected line of section. So this is the vertical section of the proposed well. And I'm using a seismic, depth-converted seismic backdrop of a colored inversion. I'm using the new GVERSE inversion tool to do a colored inversion. This is an acoustic impedance inversion. If you cross-plot acoustic impedance against brittleness, you'll see there's a linear relationship. So acoustic impedance can be used as a proxy for brittleness. So the red areas are areas of high acoustic impedance. This is the top of the Niobrara, and this is the base of the Niobrara, and this is going to be my target zone within the Niobrara as it's currently modeled. Now in 3D, let's turn off everything except my line of section. So there's my line of section on which I'm going to be doing the well plan. And I can center this object by clicking on it and going to the focal center and simply rotate around it so I can see what I'm doing. And again, I can go to the properties here and I turn on the seismic backdrop, and it's showing that colored inversion, depth converted seismic backdrop, just like I'm seeing over here. So let's go ahead and make our well plan. I'm going to highlight that well. I've already got it, the well header in the database. So I can right click and launch GVERSE Planner. GVERSE Planner is another one of our GVERSE plugin applications that allows us to do on-the-fly well planning. It will make a mechanically drillable well plan based upon the dogleg severity of the approach and the lateral angles. So we'll put that in the background. And notice my cursor now turns to a crosshair. This is the orthogonal projection of the well we're going to plan. It's being orthogonally projected right into the line of section here. So I'm going to go ahead and click right on the surface. It's going to put that into the database. It's going to put it into a well planner, and it's also going to be putting it into the geomodel. So let's make sure I've got my proposed well group turned on, and I do. Let's get the right one here. There it is. And let's do our next target point. And as I make a couple of target points, you'll see it'll update in the 3D as I'm building this. So over here in the 3D view, you'll see that I'm building that well plan right into the projected line of section. Let's do a few more. Now notice that my target surface is really above where my inversion is telling me my high acoustic impedance and therefore brittleness is. So let's go ahead and honor the seismic data to get a little better plan on where we're going to drill this thing. And we'll do a couple more target points. And maybe one more right there. Okay, we'll pause for now. Let's go over to the 3D view. And let's see if we can go and get that to go full screen. There we go, that's full screen. Let's focus in on what we've done here. Now I can go ahead and just hide my cross section for now so I can see exactly where that is in 3D and turn on the surrounding surfaces. Now the Carlisle was below it. The Niobrara was above it. Now you can see that's encasing the well bore, but it's hard to see. So we have these new clipping options that enable us to clip any kind of 3D objects. Right now it's going to be clipping the surface and faults, but I can also do a clipping of the wells, cross sections, or the map image. And let's zoom out a little bit and take that clipping surface and move it right in so I can see right where that well bore is in relation to the encasing upper Niobrara and the Carlisle surface. I can also turn on my Niobrara target. Again, remember I departed slightly from the target surface just because I was using a guide based upon the seismic. But if I turn on my cross section again, you can see everything is now together. You can see right where you're putting that well bore. All right, let's go ahead and finish up our overall interpretation here. Let's go ahead and deactivate our 3D region. And let's go ahead and construct our fully formed model. Let's turn on our well groups. We'll turn on all the surfaces, the faults. And one more thing I want to show is the dynamic generation of the fault polygons. You can see these faults are cutting a number of these surfaces. If I turn on the fault offset tool, it will automatically generate polygons throughout all those different surfaces. Let's go ahead and turn off the faults and let you see where those fault polygons are showing up. You can see the disruption in the contours here. That's where the fault polygons are automatically generated on the upper surface. And you can see on the map, again, our fault polygons are generated on the map surface. Again, everything is accessing the same 3D object in memory space. So again, what you see is what you get. Let's turn on all the fault surfaces. Let's turn on all the cross sections. Let's turn on our map image, and let's move that map image down to the bottom of our screen. And there now we have a nicely fully formed 3D geomodel with interpolated cross sections, fence diagrams, and a well plan. You like this, you can take a snapshot of it and you can save it out there. We'll just go ahead and take one I've already built for you. And you can show this thing. It's on my desktop. It's a little hard for me to find right now, but you can take these any images you have in 3D and save them out to a ping. That way you can put them into any document that you may have for reporting purposes. So I hope you've been impressed with what we're doing with the new GeoVERSE geomodeling, but you say, well, look, I really like what I've done, but I've got tens or maybe even hundreds of X-section cross sections out there, and X-section works really well for me, but I really would like to try this, but I've got all these X section cross sections. So what do? Well, there's no problem. So here's X section, and I'm showing another interpolated cross section, a well-to-well cross section through here. We now have a common format between X section and Smart section. So to get your X section cross section into your GVERSE Geomodeling interpretation, you simply save as and change the cross section type to this new SSDX format. That's our common format. Save it into the interpretation folder. Once you do that, it will be available to you in the cross-section list over here in the map view. So here it is, and I'll go ahead and open it. And I'll put it alongside of the X-section cross-section for comparison. And you see, we actually have better interpolation over here in Smart section than we even do in X section over here. But again, it captures the same wells, and we've been able to reproduce 95 to 98% of the common features, formatting features between X section and cross section. So in many cases, you simply just save it over, open it up, and what you see, again, is what you get.